You know, semiconductors, they're the brains inside pretty much everything we use. Your phone, your car, those gigantic data centers that run our entire digital world. But have you ever stopped to think about where these incredibly complicated things actually come from? The answer, it turns out, tells a story about our whole world.
So let's start with a really simple question. Could one single country, no matter how powerful or rich, make a cutting-edge computer chip all by itself? From the initial idea to the final product? Could they do it?
Yeah, the short answer, it's impossible. Just flat out impossible. The real story here isn't about one nation dominating everyone else. It's a story of deep and maybe even dangerously fragile global interdependence. A great way to think about this is like a global relay race. It's this incredibly complex dance where a baton gets passed from one specialist to another, from one continent to the next. And here's the key. No single runner can finish this race alone. It just can't be done. All right, so let's start with the first leg of this race, the design. This is where the chip is still just an idea, a blueprint on a computer. And this stage, well, it's almost entirely dominated by the US and the UK. Before anyone can even think about building a chip, engineers have to design this virtual city with billions of tiny transistors. And they're not doing it with a pencil and paper. They use this mind-bogglingly complex software called electronic design automation, or EDA. It's basically the secret language that's used to write the story of every modern chip.
And here's the thing. To make this whole process even possible, designers don't start from scratch every single time. They license these pre-designed, pre-tested circuit blocks called IP cores. Think of them like super sophisticated Lego blocks, proven components like a CPU core that you can just drop into your bigger design.
So who makes these foundational Lego blocks? Well, when you look at the numbers, it's pretty staggering. Over 90% of this critical IP market is controlled by companies in the US and the UK. They own the fundamental architecture of our digital lives. Okay, so the design is done. The baton is passed. But to turn that digital blueprint into a physical thing, you need a machine. A machine so complex, a lot of people thought it was literally impossible to build. And it comes from one, and only one, company in the world. 100%. That's the market share for the single most important piece of manufacturing equipment on the entire planet. 100%. I mean, that's not just market leadership. That is a complete and total monopoly. A single company, ASML in the Netherlands, is the only one that makes these extreme ultraviolet or EUV lithography machines. Without these things, which are about the size of a city bus, you simply cannot make an advanced chip, period. This makes ASML the most critical choke point in the entire global tech ecosystem.
But get this, and this is what's so wild about this whole story. Even that monopoly is really a team effort. ASML is more like the master conductor of its own global orchestra. The ridiculously precise mirrors and lenses come from Zeiss in Germany. The incredibly powerful lasers come from another German company, Trumpf. The flawless materials for the stencils come from Japan. So you see, the monopoly itself is built on a network of other specialists.
All right, so we've got the blueprint, we've got the magic machine. Now it's time to actually make the chips. This brings us to the middle of the supply chain and to a business decision that basically split the entire industry in half. And this is where you see this really clever split. On one side, you have what are called fabless companies, mostly in the US, like NVIDIA or Qualcomm. They pour all of their energy into designing the world's best chips, but they don't own a single factory. Then, on the other side, you have the pure play foundry, a model perfected by TSMC in Taiwan. They don't design any chips at all. Their only goal is to be the best in the world at manufacturing chips for everybody else.
And the result of that laser focus? I mean, just look at these numbers. It's just wild. Taiwan's TSMC makes about 62% of all the world's chips by revenue. And for the really high-end stuff, the chips that power AI, that number is even higher. South Korea's Samsung is a pretty distant second. So yeah, the world's workshop, it's pretty much in one neighborhood.
So, you'd think we're done, right? We've designed it, we've made it, but there's a final leg to this race. Packaging. Now, for years, this was kind of the boring, low-tech final step. But as it's gotten harder and harder to just shrink transistors, what we call Moore's Law, this final stage has suddenly become the new high-tech frontier. You see, since we can't just keep shrinking transistors forever, the new game is all about advanced packaging. This is where you take multiple smaller chips, or chiplets, and you weave them together so tightly that they act like one single massive superchip. It's absolutely essential for modern AI chips because it lets the processor sit right next to its memory, making it unbelievably fast. So what does all this mean? It means that our massive hunger for AI has turned this final, once kind of boring step into another massive high-tech choke point. And guess what? Access to this cutting-edge packaging capacity is once again almost totally controlled by TSMC in Taiwan.
Okay, let's just take a breath and zoom out for a second. When you look at the entire chain we've just run through, it is an absolute marvel of global efficiency and cooperation. But the very thing that makes it a marvel, that specialization, is also its greatest weakness.
So here it is, the whole race, laid out from start to finish. The baton gets passed from the US and UK for the core idea, then to the Netherlands for the impossible machine, then over to Taiwan and South Korea to actually make it, and then right back to Taiwan for the high-tech packaging. You can see it right there. No single country, not one, can run more than a couple legs of this race at an elite level. And this table, this is basically the receipt. The numbers don't lie. All the way down the value chain, from software to equipment to manufacturing, what you see is a series of monopolies, or near monopolies, each held by a different specialist in a different country. This is the definition of interdependence. And that really brings us to the core issue we're facing today, right? This entire system, this amazing, efficient machine, it wasn't built by governments thinking about national security. It was built by companies chasing profits and performance. It was designed for economic efficiency, not for geopolitical resilience. And that's the vulnerability everyone is now scrambling to fix.
So, where does that leave us? We're stuck with this huge, open question. This deeply interconnected, incredibly fragile supply chain. It literally gave us the modern world as we know it. But now, as we're entering a new era of intense competition between great powers, what happens next? Does this marvel of cooperation survive? Or are we about to see it all break apart?